the BatMode module. This is an add-on that allows an existing quadcopter to hang land like a bat. Instead of draining the power of the drone by hovering or landing in a risky location, drones can just perch and monitor targets for extended period with our BatMode add-on module.
You're listening to the Drone Radio Show podcast, the show about drones and the people who use them for business, fun, and research. Hosted by Randy Goers.
Hello, everyone. This is Randy Goers, and welcome to the Drone Radio Show podcast, episode 436. How can drone swarms bring value to the commercial sector? For that question, we head to Claremont, Florida, to speak with Kevin Hernandez and Dutch Alessi of Virtual Reality Rehab, or VRR. Founded in 2009, VRR is a pioneering research and development company with a bold mission, harnessing virtual and augmented reality technologies to push boundaries. With over 20 years of collective experience, their team specializes in creating innovative, multi-platform solutions for unmanned vehicle systems. Now, VRR is making waves in drone warfare with a brilliantly simple idea called the HellHive. Picture this, a low-cost, portable shipping box that doesn't just store and transport attack drones, it launches swarms of them, guided by their smart HoloWarrior software. This isn't about building drones, but supercharging them with tech like BatMode for stealthy ambushes or scalable swarm assaults, all while keeping costs down. Imagine a cardboard box transforming how militaries deploy overwhelming force. With small military contracts already secured, VRR is now positioning its products for the commercial sector. Leading the charge is Kevin Hernandez, VRR's Chief Operating Officer. Kevin directs R&D in electrical engineering, overseeing the integration and deployment of unmanned systems. He also spearheads product development, marketing, and sales for VRR's Holo accessories and B drones. Alongside him is Dutch Alessi, Chief Scientist, who collaborates with engineers and partners to unlock new swarm capabilities, driving innovation at every turn. In this episode of the Drone Radio Show, Kevin and Dutch talk about VRR's journey, their revolutionary HellHive and HoloWarrior systems, and how they're bridging military prowess with commercial potential. But before we hear from Kevin and Dutch, I want to stress that your support is the heartbeat of my podcast. Every episode is crafted with you in mind, and your generous donations ensure I can keep delivering the content you love. Whether it's the price of a coffee or a more substantial contribution, every bit helps to defray the cost of production. Donate today and be a vital part of the podcast's continued journey to greatness. To donate, go to droneradioshow.com/donate. And if you can, please subscribe to the podcast on your favorite platform and leave a nice review and rating on iTunes, SoundCloud, or Spotify. It really helps improve the podcast ranking among the many thousands of active podcasts today. And by the way, if you have a great story on the use of drones that you'd like to share in a podcast, contact me at randy@droneradioshow.com. So let's learn how drone swarms can provide value in the commercial sector with Kevin Hernandez and Dutch Alessi of VRR. Let's pick up the interview where I ask Kevin and Dutch to introduce themselves.
So I'm Kevin Hernandez. I direct operations in VR Rehab. We also call it VRR. I'm an engineer with a background in robotics and passionate about leveraging technology to come up with innovative solutions. In this case, particular solutions for warfighters to enhance unmanned vehicle capabilities.
My name is Dutch Alessi. My PhDs are in computer science and physics. I'm the chief scientist at VRR, collaborating with the other scientists and engineers, along with multiple team partners. Really excited about working with new classes and types of swarm capacities.
Kevin, tell us about Virtual Reality Rehab. What does the company do?
Mainly, our missions are associated with enhancing drones for swarm warfare and civilian operations, of course. That's what your audience is interested in. We develop cost-effective add-on modules that improve this drone capabilities for military and commercial uses. So that's our game. It's developing add-on modules. We also do augmented reality for manned and unmanned teaming equipment or kits. Our main software, our flagship here, is called HoloWarrior, which is a software that brings advanced situational awareness through some visualization tools that help the warfighter make faster, more accurate decisions by we call it making invisible threats visible. That's our motto there. Our three main technologies, one that I already mentioned is called HoloWarrior, the software. Then we have this other add-on modules like BatMode. It's a game changer in ISR modules. This extends the duration of the drone flights. And then we have HellHive, which is a modular swarm warfare system that allows drones to be stored and launched and deployed from an existing container. Overall, we're committed to bringing this equipment to warfighters for next generation capabilities and exploiting the add-on module capabilities.
What sets VRR apart from other companies offering similar services?
We're trying to deliver this focused technology as inexpensive add-on modules for existing drones that are out there and for the new emerging ones. Instead of relying on completely new and costly platforms, we often take the approach of open source code, open source hardware as well. That reduces the cost a lot and makes this technology more accessible. Our innovations are directly solving challenges in mission durations, employment flexibility, and swarm warfare, as I mentioned before, and all at the fraction of the cost of traditional solutions. For example, the BatMode module. This is an add-on that allows an existing quadcopter to hang land like a bat. It'll be gripping onto wires, tree branches, and other surfaces or other horizontal, I should say, structures, fixtures to enable persistent intelligence, surveillance, and reconnaissance. And it's a simple concept, but has a lot of potentials. And it's cost effective in comparison with other persistent ISR solutions that are out there. And this has other implications for commercial uses. So basically, instead of draining the power of the drone by hovering or landing in a risky location, drones can just perch and monitor targets for extended periods with this method that's enabled with our BatMode add-on module.
Does the system operate autonomously, or does the pilot manually locate and guide the drone to its target?
Yes, that's a great question, Randy. So we have different flavors of this because we're conscious about the cost that we have within an automated solution. So we have our AI self-parking method where the pilot selects the area of interest and then the drone goes and automatically identifies a suitable landing fixture and then proceeds with the automated landing maneuver, the perching maneuver. And then we have all the way down to basically a simple skyhook that we adapt on any existing drone. And then a pilot that can teleoperate this drone can manually land the drone onto it and also take off afterwards. So you land, you disarm your drone, you save up a bunch of power. The drone's still on, the camera's still on transmitting, for example, or any sensors that you have attached to it, but you're no longer draining the power by just hovering, right? So we showed that the endurance is increased by 10 times, and this is just with today's affordable batteries. So to address your original question, no need to wait for some breakthrough in high energy, lightweight batteries that may or may not happen in the future. And even if they do arrive and they are available for, as a commercial off-the-shelf thing, then still the BatMode modules will increase their duration by at least 10 times.
That's the BatMode module, and there are others for swarming.
There are others that enable more swarm warfare capabilities. For example, we have BatMode enabling roosting swarms, where drones take turns staying on watch while others enter in what we call a deep sleep mode. So this means that they can remain operational for days or even weeks and then activate and execute the rest of their mission within seconds. When a target or a point of interest is detected, then you wake up the drone or drones and do and execute that. So this is something that modules like BatMode enable. The other one, I think I touched on this a little bit, transforms loitering munitions. So this is a good example how we're doing things differently. There are UAV solutions that are focused on having the UAV, the drone, just flying and being up there the whole time and loitering. But with bat mode, you can hang land in a advantageous position that's around you and just save battery there, wait there, and then come out of there whenever it's actually needed. And this way, the drone stays in position for far longer, at a tiny cost of what the U.S. is currently paying for loitering munitions. And then we have the HellHive add-on modules. These are modules that you put on existing quadcopters to enable them being stacked and launched from within an existing container. The size of the container, it could be even like a cardboard box up to a ruggedized military box for pallets. We have different sizes depending on the drone. So it's a one-time thing that we do for a particular drone design or drone model. And then from there, you can just replicate the add-on modules and use the benefits.
So is it a box system where a number of drones are stored and they all just fly out on command?
Yes, sir, exactly. And when you have multiple of these boxes, because it's a scalable technology, then you can launch them in layers. So you launch first layer of a swarm, then the second one. Each of them can all have their own mission, or they can all have the same mission, the same target point to land, to hover. We have different uses for this.
Given your description, it sounds like military applications are a primary focus. Can you walk us through VRR's origins, its core customers, and how it's expanding into commercial use?
VR Rehab, or VRR, as I mentioned, the woman-owned business with over 25 years of experience in research and development, primarily supporting our warfighters, of course, as I mentioned, through innovative technology. We actually started with rehab-focused projects in virtual reality and mixed reality for medical and training applications. But over the time, we adapted to meet the needs of the defense sector, particularly in enhancing situational awareness through our know-how in VR and MR. Then we transitioned to drone-based solutions because we needed cameras on the sky. Eventually, we specialize in the two things that I mentioned at the beginning, enhancing drones with swarm warfare and civilian operations, and this augmented reality for manned and unmanned teaming.
What prompted VRR to explore commercial applications for its technology?
Mainly, VR works through SBIRs, through small business and innovation research projects. And one of the requirements for those projects is to look into transitions, commercial transitions. These transitions could be on the DoD itself, so getting military warfighters to use this technology in different ways, and they will tell us how they can use it. And also on commercial transitions so this would be for the civilian sector.
Do you manufacture your own drones or modify existing models?
When we have to, we have manufactured our own drones just to get across and complete the missions, more focused on augmented reality and enhance situational awareness. But this is just to prove that we can have this working even with our own drones. But our main focus is enhancing existing technology from other manufacturers. So there are different companies that we have tried our add-ons with and have really great success stories. And that's the purpose, just trying to complete and not compete.
I think swarm technology is well understood in military applications, but what are its benefits in commercial sectors?
For example, with swarm technology, that we know it's a game changer across many industries. Instead of relying on a single drone to cover a large area, multiple drones could be working together to complete a task faster. This is just logic or intuitive to understand. So we're providing redundancy here with our solutions, and this way we can adapt dynamically to any changing conditions. So for example, for the infrastructure inspections, a swarm can inspect bridges, pipelines, or power grids in record time by covering different angles simultaneously, reducing the cost, and even improving safety. For disaster response, we actually had a project in the humanitarian assistance and disaster response. After a natural disaster, a swarm can quickly map affected areas, locate survivors, and even deliver critical payloads like water, food, blood, things like that are much faster than ground crews, or even they could even not have access to those objectives. This is where HellHive, a concept for deploying swarms, makes it cost effective and add that swarm capability to your existing drone. So companies that are listening, they have a drone that has many capabilities. Well, with HellHives, we can stack them up and have this capabilities enhanced in a cost-effective way. Another example of how we can use HellHives in the commercial area, you mentioned agriculture. So farmers can deploy a swarm of drones as well for precision spraying, soil analysis, or even real-time crop monitoring, for example. In construction as well, we can automate progress by tracking or doing structural inspections, as I know some cell companies do for their towers, and especially for environmental monitoring. So we track wildfires and detect pollution in water bodies or monitor deforestation. Things like that are the applications that we're looking at within our SBIR projects.
Does the container not only allow drones to launch, but to return, recharge, and store them all in the same spot?
Similarly to the BatMode module, we have different versions of this depending on the cost benefits, right? So more complicated solutions that we have will cost more. That depends on the customer and their needs. There's recharging inside of the HellHive. There's something we call HellHive Power Tower, where you have a landing structure that sticks out from the HellHive itself. And so a drone that's equipped with the HellHive add-on modules and with the BatMode add-on modules can come back and land on what we call the HellHive Tower, land there and recharge while hang landed. That's another version. We have HellHives that are all clear, and while the drone is in the box and recharging, we can still benefit from the sensors the drone have, the cameras, obstacle avoidance features, and things like that. Again, this depends the drone itself and how we're enhancing its capabilities. So if you have the HellHive mounted on a vehicle, then right there you just provided the whole vehicle with those same capabilities the drone have while it is just resting inside of the clear HellHive. Just to mention some examples.
Do you manufacture the Hellbox?
Yeah, and by manufacturing, we mean we adapt existing containers. This drives the cost way down, which is ultimately our goal, have a cost-efficient solution, something readily available, because we're talking about numbers here, right? So if we're talking about a large number of drones for a swarm, then our main supply chain approach here would be to take existing containers in manufacturers that produce those containers, then adapt them to mount the drones and make the drones fit in those existing containers. This just increases the response time.
Now, as I understand it, the HoloWarrior system enhances situational awareness. How does it achieve that?
Right. So HoloWarrior is a software that we develop throughout different SBIRs, different projects. It uses mixed reality to show you virtual information that is not there, but it is showing you the information on a screen where you're looking at the real environment. This is another way of saying augmented reality, but when we're talking about mix, is making it look really intuitive, really as if it is there. So this piece of software enhances situational awareness that way because you're looking at your real world, but on top of that, you see, for example, hidden threats that you don't know are there, or they're invisible to the human eye. And this piece of software runs in something as cheap as an Android phone, to a tablet, to computer, and then to head-mounted displays like VR goggles and HoloLens, and even in some projects we're porting to the Army's IVAS headset.
Is the HoloWarrior primarily a training tool, or is it used for live operational scenarios?
Training, it's one of the main use cases for the commercial uses, right? For the civilian commercial uses. And for the military uses, This, we do want to use the software to see, for example, threats that are usually not there or that are mapped in 2D maps, for example, and the military use 2D maps for that. So they are aware of the threats, but it's just the way that they see them is not efficient, not intuitive. The way we do it with augmented reality and mixed reality in HoloWarrior, we are actually enhancing this visualization of 2D maps into the foreground intuitively, and we link it with something that we call case guidance lines, mini maps, and other features within our software. That just the important part is that it increases awareness and for faster, 3 to 5 times better situational awareness and 99% decision making improvements. These are data that were collected in a study that Colorado State University did with Dr. Chris Wickens. So this is an independent university that checked our technology and found out those improvements. For civilian applications, we're looking at, again, training. We're looking at navigation improvements. So you'll have cues, for example, when driving, you're driving in a road that might not be mapped. And with this software, you can have what we call safe lanes to guide you through the safe lanes and not get out. So in your screen, you'll see the safe lanes overlaid on top of the real camera view that the back-facing camera of a tablet can provide to you.
Pulling together and displaying all of the data sets, what's that look like operationally?
Yeah, so you've probably noticed that there are different data sets of information coming from many different technologies, even using drones that collect this information with sophisticated sensors or via satellite. They can transmit that information back to a server, and the server connects to the tablet or the head-mounted display goggles or laptop that's running our software HoloWarrior, right? The person using this software, we call it the swarm operator. So they'll have all this information just as numbers in our software HoloWarrior, and then HoloWarrior transforms it into something that's visually appealing and intuitive to understand. Most of our developers have a lot of experience in game developing. So the interfaces that we develop are really intuitive for the younger generation, especially. They look like video games. The graphics are amazing. And we have a lot of good feedback from experts in the field that otherwise won't understand the data that they get in a graphical way, right? So it's kind of like we asked them when we were developing our stuff, how do you imagine that, for example, a radiological hazard cloud, how does it really look like in your mind? Because it might be invisible, right? But how do you think it looks like? So those are the things that we present in HoloWarrior and augmented reality. And so the drones here are ways to provide us that input information, but not only that, but act upon that, right? So there's the other person in the team, what I was calling the man-on-man teaming. One person is a driver, using HoloWarrior for input, for avoiding stuff based on what they see, and the other person is the swarm operator that can do something about that information by launching drones that they have stored in a HellHive container on their same vehicle, on the let's say the bed of their pickup truck. They open the box and launch the drones from inside the car. That way they're safe. They can be proactive about a threat, about getting more specific details on a thing that's of their interest.
Suppose in an industrial disaster, like a gas explosion, could drones track and visualize the airborne contaminants to aid the response teams?
Yeah, this is a really exciting use of our technology. We have an ongoing project that's very related to what you're talking about. So the way we're improving the processes of scanning or monitoring hazardous areas, chemical, biological, radiological, or nuclear areas, right, is by replacing the person that's going out there first with a drone, at least one drone, or even with a swarm that launched from a HellHive. And each of this drone part of the swarm will be equipped with detectors from really important companies that are partnering with us. And these detectors equipped on the drones are launched out there. They scan, and in real time, they provide that data to our software, HoloWarrior, which transforms those numbers into something visual, something that the subject matter expert, the hazmat expert, will understand faster to make decisions of going, not going in there, or I should bring this other different piece of equipment, or mainly, or I would say the first thing that they want to do is to define cold and hot areas to not get into the hazardous space.
You mentioned BatMode for conserving energy. How could this benefit law enforcement or emergency operations?
This is something that is being done currently in different ways, but the main example is just having a camera out there placed for more than 24 hours, giving you continuous video in places where you otherwise don't have cameras. Does that make sense? So if you launch a drone with a BatMode module and you don't need to have it hovering there the whole time, just hang land and watching, it's kind of like if the police officer just installed pretty quickly a surveillance camera just using one drone. If you have more than one, then you can have 24/7 video monitoring an area or acting upon a certain triggering event that they decide, right? So that's where the other swarm use case that I was talking about, the roosting approach, comes to play, where you can have most of the drones sleeping and then just one of them is the one monitoring. And when it's time to act, then you launch all of them, one of them.
What kind of endurance improvements does a rusting drone provide over one that remains in active hover mode?
In our preliminary test, it was discovered that we had increases of 10 times. So 10 times the duration of the flight in normal conditions with your drone. That's what you would get if you would, instead of just hovering, you would hang land in an advantageous position, as I mentioned before, like a tree branch or something like that, and then continue the mission. When you're done with your mission, you take off again and go back.
I'd like to get Dutch involved in the conversation. Dutch, how do you see automation shaping the future of commercial drone services? And what challenges still need to be addressed?
Essentially, we're 180 degrees directional from these very expensive billion-dollar efforts where they're going to have a bunch of AI drones talking amongst themselves. Even things like the replicator program are too expensive and too complex. Just our pragmatic approach is that these types of large-scale efforts that are underway actually still use communication between the drones themselves or at other places. And what that does is still keep you open to enemy activities that are jamming or spoofing and that kind of stuff. So our simplistic, pragmatic approach is to do what we call fire and forget. So while the vertical stacks of drones are in a HellHive or in multiple HellHives, we can launch them all, but we pre-program the locations. It's fire and forget, more akin to something like a javelin weapon than some kind of complicated AI collaboration. And once those are programmed, you don't even have to have a radio on the drone. We're not talking to it anymore. It's going to go out and do its mission. It's really good against static targets or delivering to known locations. If you add an automated target recognition module onto the drone, then you can hit moving targets or moving survivors, whatever you're looking at that way. But our main approach is to be fire and forget in dark. We have a module that we put on there called Pathfinder, which allows you to operate in GPS-denied operations. So completely dark without any kind of communications going back and forth between the drones. And HoloWarrior allows you to do scripting of very complex swarm missions. So you can have a bunch of different deconflicted drones approach a target or logistics place from multiple angles, multiple speeds, multiple altitudes, so as to defeat any kind of counter-UAS that is being used against it, or just to do good traffic control to bring logistics in a safe way. There's also, based upon BatMode and HellHive technologies, you can put a HellHive on anything, ground vehicles, ships. We even put them with one of our DoD contracts on larger motherships. And what we're able to do is the mothership, with its increased range and payload, will take an entire swarm to an area. And then while it's still in flight, air deploy the swarm, they'll go out and do something like chemical, biological, radiation, nuclear detection, and then come back and using the AI self-parking mode on our BatModes will then re-land onto the mothership, whether that's just to be recovered and it goes back, or in the more advanced models can recharge if you've got significant battery resources on the mothership. So those are just some of the ways that we see VRR being different. We're not going to do the really expensive stuff where everybody's competing. We're doing the inexpensive stuff, fire and forget in dark.
Could a HellHive be deployed for search and rescue missions, assigning drones that cover different areas autonomously?
Yeah, in the civilian space that you're talking about, it's fine to communicate with the drones. So if we had something like the Skydio X2 or the X10s that are out there with the great IR sensors on them and all that sort of thing, we would just add our modules. The mothership would go out, launch the Skydio drones from the HellHive. They're really good with the Skydio drones are specifically very good at collision avoidance and automation. And they would go out and do the mission, and they can report real time back to the mothership, which relays a signal back. Or, if you're relatively close, they could communicate to base stations or the firefighters, whoever's on the line that needs that information right away. Without naming any of the networks that actually we can name one. There's a thing called TAC Civ, which is a great networking tool used by a lot of first responders. We're already integrated with that. So as we find information, we can pass that back to the network so everybody sees it, and vice versa. Any information that comes across the network can be displayed in augmented reality for our drone or swarm operators.
How do your drones fit into the broader military strategy? Are they coordinated for surveillance, attack, or other missions?
Most drones for military uses are still ISR. So we fully support that, whether it's tele-ob, it goes out dark, comes back with a chip recording of everything so that, again, you couldn't be jammed or spoofed. But for providing lethal payloads, we have arrangements with several munition manufacturers where they give us very realistic inert munitions. So they give us that they're proper size, shape, weight, center of gravity that we deliver on our drones. So it does everything but go boom. We have agreements with several different companies that do make things go boom, but there's a thing that we may talk about a little later. In the United States, there's a thing called the fuse board, and they have the best of intentions to make sure that it's safe. But they make it very difficult to make lethal drones in the United States. It requires millions of dollars and years to get through the fuse board process, even though we're using munitions that are already carried in the backpack of soldiers. So the munitions are already safe, but just something about fuse board makes it a very slow and expensive and painful process to get lethal drones authorized for the United States. Now, some of the drone manufacturers we work with ship their drones to Ukraine, and somebody, a Ukraine patriot in their kitchen, is able to add lethal means to the drones that we augment for these guys with modules and or provide our software for. So the answer is it's hard in the United States because of regulations and fuse board. There's no technical reason that it's not easy to do.
Can different drones within a HellHive perform separate missions?
Randy, that's a perfect question. We just came back from a demonstration in California on a military base, right? Let me describe exactly the situation that you had. So we took a rented pickup truck, put our HoloWarrior manned-unmanned teaming kit onto the rented pickup. So the driver was able to see AI, safe transit lanes, and avoid threats. And the passenger right next to him was running another copy of HoloWarrior, being the swarm operator. So on an abandoned runway, the pickup truck goes down, and we saw this evil orange cone with a label on it that said enemy IAD. And what the driver was able to do was mark that threat, and that went out to this network like TAC Civ to everybody there that he's marked it. Then the drone operator next to him sent out a drone that landed right next to it with a disruptor charge. Again, we didn't make it go boom, but we could have done that if they would allow us. And we eliminated the enemy IED. So then we take it back off the network, it's safe, and we continue down our AI transit lanes. Further down the runway, we come across another evil orange cone with a label on it, dirty bomb explosion. So it's a radiation threat. So again, the driver was marking it, and then the swarm operator sent out a drone with a handheld radiation sensor. Actually, it's an emulation that we do because we're not allowed to use real radioactive stuff. But it flew then a grid pattern, and it characterized where the hot spots were on this dirty bomb explosion, and allowed the MUN team, man-to-man teaming group in the front of the pickup truck, to reroute the AI safe transit lanes around the threat so that the follow-on units could actually go through. Then they started to return to base, but then a third drone was flown out of the HellHive by the swarm operator, and it landed in a nearby tree. And it stared at the cleared area that had just been cleared of the IED and the dirty bomb problem, invisible threats. And what it does is stare at that, because our enemies have a great sneaky plan that after we clear an area, as soon as we clear it, they run back out and put more mines in the way. So with the persistent ISR that the BatMode drone sitting there staring at, that prevents the enemy from running back out there and remining the area and catching our convoys or our fighting forces off guard. So that was just one experiment to illustrate. And that was just done a week or two ago. We're constantly doing these types of exercises with real war fighters that tell us what's good, what's not, and how to constantly do agile development to make it better and better system for the war fighters primarily, and secondarily for the dual use civilian sectors.
How could this technology be applied to mass casualty events?
One of our university team partners is Arizona State University, and we're actually recreating some of the train wrecks that have toxic spills and those types of things, where in our mission rehearsal mode, it's the actual terrain, it's actual images of the trains and those types of things, and they get to practice how could you have used a swarm to do better, faster decision-making versus what they did, which is, a few guys on the ground and maybe a helicopter or two.
I assume that military personnel undergo ongoing training for these systems, but how will you transfer that knowledge to civilian operators who may be unfamiliar with the technology?
Our whole philosophy, if you're a fan of science fiction, is Ender's Game, right? So what you're able to do with HoloWarrior is you can pull in any portion of the Earth in seconds. And then you can actually mission plan. It's basic mission planning where you can have scripted entities and those types of things, put in different objects, buildings, vehicles, that kind of stuff. And then you have a mission rehearsal mode where you can actually use the same GUI interface that HoloWarrior provides operationally and run the whole thing. And you can do your what ifs, and you could do different versions of it. And this is all savable in what we call a resource file. So you do your various mission rehearsals to get your plan optimized. Then if you're going to have first responders or somebody else go in there, they can actually practice while they're driving or flying into the disaster zone with a simple laptop or even just a smartphone. They can practice what they're going to do when they get there. And then just by flipping a certain software toggle, they go from virtual mission rehearsal to actual operational use using the exact same GUI. Because we use realistic 3D, photorealistic geospecific terrains, it even looks the same. We even have deals with one of the companies that scans in the entire Earth every 24 hours. So the data that we have to mission rehearse with can be as recent as the same day.
Regulations can be a barrier to drone adoption. What challenges do you face with the FAA and FCC policies?
The FAA lack of support for swarm testing even is a hindrance. We have one particular airfield where it was a closed prison, and it's still FAA restricted airspace. So we're able to do large swarms up to 15,000 feet on 1,200 acres, but we have to go to that facility. We do local testing, but because of FAA regulations, we're typically limited to, we're a distributed organization, but we only have 4 FAA 1075 pilots qualified right here in Central Florida. So we can only fly 4 swarm at a time at any place but this nice facility or military bases. We're able to do those with the proper waivers and all that. But the FAA is a hindrance in being able to do large-scale swarm testing.
Is there a clear pathway for integrating swarm technology into regulatory frameworks?
Again, this is not the company representation. This is just my opinion, but the FAA process to get anything done, including beyond visual range use, is onerous, slow, and fraught with failure. So again, they don't make it easy for us to do any kind of realistic testing in the large swarms. The other hindrance is for swarm testing within the United States, where they get to control things, is the FCC, where we're only able to chop up the frequencies that we're using to have 20 drones controlled by one laptop or one tablet or one smartphone. We could do much larger ones, much larger swarms per base station, but the FAA doesn't allow us to chop up the frequencies any more than 20 per. So that's not as much a hindrance. If I had to rate them, the fuse board is the greatest hindrance. The FAA could do better helping us, and the FCC could also help us do better swarm testing.
Does the FAA and FCC collaborate on these issues? Or do you have to navigate both agencies separately?
It's figure it out all on your own, and both are painful processes. As a small business, we don't have a dedicated paperwork group to go figure out all the FAA regulations or the FCC. So they don't make it easy on a small business to get forward in the swarm business.
Are there emerging applications in the civilian space that you find particularly exciting or groundbreaking?
There's some folks that are starting to do it. Skydio is doing a pretty good job with their new docking station, but they're basically doing one drone at a time. We see a future where you need to do periodic inspections on, say, a bridge or a series of cell towers or whatever infrastructure you're talking about. Instead of the current process of putting two guys in a truck and they drive out there at exorbitant rates and then do a scan every once in a while, you could attach a HellHive to a tower and it could automatically scan the lines or the towers or whatever else you need to do. If you have some sort of grid power or you even have solar cells on there to do recharging, it just takes the human out of the loop. So our whole thought process, our whole approach is to take humans out of the loop wherever possible. So the HellHives allow you to safely store it. You can ship it between locations, and then it can rapidly, automatically deploy the swarms, whether it's from a single HellHive or a coordinated group of HellHives that scales to very large numbers. So the idea is that you don't need humans. The military applications are pretty simple. If you're a fan of the stories about Pandora's box, if I'm in a retreating, or as they like to call it, a retrograde motion, I just leave a couple of HellHives on the ground. And as the enemy gets close enough to be identified, the HellHives open up and discourage a rapid pursuit of the good guy forces. Law enforcement, there's no reason to risk humans to do surveillance. I can take a HellHive on the back of a pickup truck, send up 4 drones, look at all 4 sides of the building, set it up so that it only sends data when a door opens or something. And instead of tying up blue suiters, actually let the drones let you know when somebody's going in and out. If you've got good cameras on there, you can do facial recognition. The idea that the swarms divide and conquer things is the way of the future. And take the humans out of the loop. There's no reason to risk our humans. You can still have their clever brains controlling the swarms or setting the strategy for the swarm, but there's no reason for the humans to do this grunt work any longer.
What's next for VRR? What can we expect to see in the coming months?
We've got several transitions that we're supporting with the military, but in general, the product that we're selling is manned, unmanned teaming add-on kits. Like I described for the California demo that we did, we take any car. We have a 2002 Toyota Camry that we've augmented with a couple of our HoloWarriors for the driver and passenger, and we actually strap to the trunk the HellHive. So in general, the way we see the market opening up, especially for our low-cost, inexpensive, expendable drones, is that everybody can have a method. Let's stay with military first. Any vehicle, whatever type, can now defend itself, right? It self-defend itself. Instead of running away or calling for help, you've got your own drone strapped to your trunk or in the back or tied to the side of the vehicle. It doesn't matter. And you can actually put the drone swarm out there to at least confuse and decoy the guy or actually attack the bad guy that's trying to get you. The same thing goes for law enforcement or fire. So instead of putting people or a helicopter or however in there expensive, you actually send out a group of drones. They form a line along the fire line. They can keep backing up as the fire progresses, but it gives you real-time information about what the situation is from inexpensive drones. We don't care whose drone it is. We like Skydio. There's another group called Dragonfly that we use. We use Lockheed Martin drones. we don't care whose drone it is. By adding our modules and using the HoloWarrior common controller software, we think we've got a value add in a small niche. Again, we're not trying to compete with the billion-dollar efforts out there, but we've got solutions right now that can benefit not just the military sector, but the civilian sector. The illustration I always give is just a simple BatMode module that we have. We can add that to any drone, do one-time testing and engineering, and then you can mass produce it. And those drones can actually hang there for 10 times the duration that the current ones do. You don't waste all your time flying back and forth. And the beauty of the situation is that they're structured in such a way that you can actually do periscope, an AI periscope mode that goes up and does grid searches, an AI takeoff mode. Again, taking the human out of the equation and being able to do 10x on existing batteries on a single charge. And like Kevin was saying earlier, if the magic batteries actually get done that they're spending billions of dollars on higher energy density and lighter weight, even if they finally come up with those expensive solutions, BatMode would still make those 10x longer. We've really spent a lot of time getting good at persistent ISR with military, and we think there's a lot of applications, whether that's with Axion or one of the other market leaders out there.
And for my final question, what message would you like to leave regarding the future of the drone industry? Kevin, how about you start?
Based on recent events, well, not so recent now with Ukraine, we've all seen different uses of the drones, right? And the future of the drones. So I think it isn't just about bigger, faster, more expensive platforms, but it's about smarter, modular, and cost-effective solutions, right? So VR is leading the way, I think, by unlocking the potential of some of these existing drones, making them far more capable than they were with really low-cost solutions. So I think that's what we need to think about and how we use drones in the future.
And Dutch, you get the final word.
Right now, many of the drone programs take a lot of time to create, and some of them don't actually succeed before they become obsolete going through the military acquisition process. So this is sort of an esoteric suggestion, but if they would treat drones as ammo, where robots as ammo, that's an accelerated system to where you can actually get something out fast, like the Ukrainian folks are able to do. So there's some acquisition changes that could easily be made in the bureaucracy of approving weapons, again, going back to the fuse board, that would really accelerate the technical advantages that we could bring to bear quickly if some of these policy or regulation impediments were removed.
That's it for episode 436 of the Drone Radio Show. I hope you enjoyed hearing from Kevin Hernandez and Dutch Alessi of Virtual Reality Rehab. I want to thank both for taking the time to speak with me. If you want to learn more about VRR or want to connect with Kevin or Dutch, check out the webpage at virtualrealityrehab.com. If you like the Drone Radio Show, then please subscribe and share. Write a glowing review on iTunes. And if you're able, donate to keep the podcast going. Go to droneradioshow.com/donate. And thanks for listening. Your support means a lot to me, and I hope you'll listen to more episodes of the Drone Radio Show podcast to hear how others are using drones for business, fun, and research. For the Drone Radio Show, I'm Randy Goers.
This has been the Drone Radio Show podcast. More information on today's show can be found on our website at www.droneradioshow.com. If you're using drone technology for business, fun, or research and would like to share your experience on the show, please visit our website and fill out a guest appearance application. And don't forget to follow us on your favorite social media channels.